Hey guys, it's Roya, and in this video I'll be going over inclined planes and forces. So here we have a slide, and Johnny is on the slide and he's shooting downward. The slide is at 50 degrees from the horizontal. Johnny's mass is 45 kilograms, and the kinetic coefficient of friction equals 0.1. So using this information, I want you to find the acceleration that Johnny experiences as he slides down the slide. So I hope you've tried that on your own, but if not, that's completely okay, because right now I'll be going over how exactly to do this inclined plane problem. So here, if we were to draw a force diagram using a normal xy plane, we'd see that we'd have to put normal force here and kinetic force and frictional force there, and then mg here, but it's pretty complicated. What we want to do is actually tilt the plane so that it's in line with normal force here and frictional force here. And then we get mg downward, but mg can be split up into, so if this is mg, we would simply sort of half erase it and say that since this is 50 degrees, that this is mg cosine 50 degrees, and this is mg sine 50 degrees. Now this way we only have to decompose one force, whereas in this scenario we would have had to decompose two. So here we have frictional force and normal force, and we'd like to look at his acceleration in this direction. So I'm going to call this the new x-axis and this the new y-axis. If we look at net force in the y direction, we see that it's 0, which means that normal force equals mg cosine 50 degrees. Now, if we look at net force in the f direction, we see that it's not 0 because he's accelerating downward. This actually equals his mass times his acceleration, and we also know that it equals mg sine 50 degrees, which is this right here, minus frictional force. So all this is net force in the f direction, and this equals ma. So we know that frictional force equals mu kn, which equals mu k mg cosine 50. Now normally we would replace n with mg. However, in this case, since it's an inclined plane, we see that m does not equal mg, it equals mg cosine 50 degrees. So make sure that you make the right adjustment here. So once we have that, we can plug it in. So that mg sine 50 degrees, which is just straight from here, minus mu k mg cosine 50 degrees equals ma. Now here, if we were to divide everything by m, we'd see that the m's all cancel, and a equals g sine 50 degrees minus mu k g cosine 50 degrees. And if we plug all this into our calculator, we see that a equals 6.88 meters per second squared.